Number 1, there are 400 bacteria in a petri dish. The number of bacteria in the dish triple every 4 hours. So we're starting off with 400, and they're tripling every 4 hours. Determine how many hours it takes for there to be 1,000 bacteria in the dish. So I'm starting with 400 bacteria. They're tripling, which means times 3, but it's every 4 hours, so not to the t, it's to the t over 4. And I want to know when that gets to 1,000. So it's an exponential equation that I have to solve. When your variable's trapped in the exponent, we need to use logarithms. So before I take the log of both sides, let's divide by 400 to get the exponential expression all by itself. And that gives me 2.5 equals 3 to the t over 4. Now that we got the exponential expression all by itself, we can log both sides. And you can either use the common log or you can use the natural log. We normally use the natural log when there's an e involved. Doesn't matter though. When we have an exponent inside of a logarithm, we can bring it down front. So log of 2.5 equals t over 4 times the log of 3. I want to get t all by itself. Well, I'm going to multiply by 4. And then divide by log 3, because log 3 is actually a number. It doesn't look like just one old number, but it's a plain old number. So t equals 4 log 2.5 over log 3. I'm going to go to my TI-84 here and type that in. 4 log 2.5, close it, divided by log of 3. Enter. So it takes about 3.34 years, not years, hours. It takes about t equals 3.34 hours. It didn't tell us where to round to. It should be more specific, but we'll round there. Titanium-44 is a radioactive isotope such that every 63 years its mass decreases by half. This is a half-life problem. How many years will it take for a sample of 50 milligrams of titanium-44 to decay so only 10% of it's left? Round your answer to the nearest tenth. Okay, so I'm starting with 50 milligrams of titanium-44. It's a half-life question, and that half-life occurs every 63 years. And that equals, well, what's 10% of 50? That's 0.1 times 50. Which gives me 5. Divide both sides by 50. 5 over 50 is 0.1, which is not a surprise because I wanted 10% left, equals 1/2 to the t over 63. We log both sides. I'm going to do that all in one step. I'm going to bring my exponent down. I'm going to multiply by 63. And then divide by log of 1/2, and type that into my calculator. So the time is 63 log of 0.1 over log of 1/2, which is approximately, so I had 63 log of 0.1, divided by log of 1/2, 0.5. So t is to the nearest tenth, 209.3. T equals 209.3 to the nearest tenth. The second part of this question says, if I started with 700 milligrams of titanium-44, how many years to the nearest tenth will it take so only 10% of the titanium's left? So instead of starting with 50 grams, I'm starting with 700 grams. Equals, well, what's 10%? Not 5 anymore. It's 10% of 700 is 70. Divide by 700. 0.1 equals 1/2 to the t over 63. Well, wait a minute. We just solved that equation. I just solved that equation there and got t equals 209.3. Doesn't matter how much you start with. If I want 10% to be left, Doesn't matter if I start with 50 grams, 700 grams, or 1,050 grams. Doesn't matter how many grams I start with. If I want to get to 10%, it's always going to take 209.3 years for this specific element, because that's how half-lives work. Doesn't matter how much you start with, you always keep losing half. So you could have went through and solved that, but hopefully you noticed that these are the same. Number 3, Julie deposited $50 into a savings account that pays 3.34% interest compounded quarterly. Write a function f of t that models the amount of money in Julie's account. So f of t equals, well, compounded quarterly. This is the p times 1 plus r over n to the nt formula. 50, 1 plus the rate as a decimal, over n. How many times does it happen a year? Quarterly is 4 times to the 4t. How many years to the nearest quarter of a year will Julie have to wait until her money doubles? Doubles, not doubles, doubles. Well, that'll be $100. I want to know when Julie gets $100. So I'm going to divide by 50. And I get 2 equals 1 plus 0.0334 over 4 to the 4t. It makes sense that we got a 2 here because I wanted the money to double. To bring that exponent down, I need to log both sides. I'm going to go over here. The log of 2 equals, I can bring the exponent down when I log, 1 plus 0.0334 over 4. I'm going to divide by 4, log of 1 plus 0.0334 over 4 on both sides. 0.0334 over 4. So in my calculator, I'm going to type in t equals log 2 over 4 log 1 plus 0.0334 over 4. 334 over 4. So when you have to type this in to your calculator, you have to be extremely careful. So if you have a TI-84, use the fraction button, alpha y equals enter. That's very easy, you type it in. If you have a TI-83, log 2 divided by, I want all of that to be in the denominator, so I'm going to open up a set of parentheses. 4 log of 1 plus 0.0334 divided by 4. 2 parentheses there. Close the log, close the denominator. So to the nearest quarter of a year, is 0.83 closer to rounding up, or is it closer to 0.75? That's closer to 0.75. So we get t equals 20.75. If you wrote t equals 21, I'm not truly concerned about our rounding issues. They'll be very clear on the regions, what we have to do rounding-wise. But to the nearest quarter, this number is closer to 20.75 than it is to 21. Number 4, determine the number of years it takes for $750 invested at a 3% interest rate, compounding continuously. We love when we see compounding continuously because that's our friend PERT. That's our friend PE to the RT. I'm starting with 750 to the 0.03. I don't know the years. I want to know when that equals 953. Because I have an E in my problem, when I log both sides, I'm not going to use the common log. I'm going to use the natural log. That number looks like a mess, so I'm going to leave it alone. So when I log both sides, I'm going to natural log both sides. Remember, when we have an exponent inside of a logarithm, he comes down front. Equals 0.03t ln e. And what's nice about using the natural log of e is 1. So 0.03t times 1 is 0.03t. And then we divide by 0.03. So on your calculator, this is what we need to type in. Do we know what to round to? No. So we'll guess. The natural log of 953 over 750 divided by 0.03. That's about 8. T is about 8. So it'll take about 8 years for $750 to grow to $953.